Good morning. Hey, Move. How's it going? Okay. Today is the 2nd of August, 2018. This is the nybbles.io daily programming stream. My name is Jeff. I write code every day because I'm crazy. And I stream it on Twitch Monday through Friday because I'm even more crazy. And I'm working on a project called Basecode, which is a new programming language that I'm designing because I'm really insane, and I'm in the process of writing a bootstrap compiler in C++. Yesterday, after the stream, on and off throughout the day, I got some stuff done, discovered a bunch of other problems, which, is par for the course. And when I woke up this morning, I was thinking, what do I want to do? And I thought, well, what would be kind of interesting would be to work on the register allocator a little bit, and maybe try to make that not so stupid, and avoid a lot of the reloading, a lot of the moves that the code was generating. And I've got part of it working. It's better. So what happens now is, let's go through this. So on the emit context, right? So we have a session. The session has, I think the context is being passed separately. Yeah, my bad. Okay. So we have, on the context, we have the session, we have the program, the terp, the everything, right? It's all on there. The assembler. And what I was doing previously was, we'll use identifier here as an example. So first, I had kind of a pretty confused concept of access, which I think I can now kind of strip out. It's looking like I won't need that anymore. And so this is the identifier element in the code DOM, and this is that class is on emit, right? So when we reference an identifier, what happens? What kind of code gets generated? Well, there's a couple of scenarios essentially. One is if it's on the stack, then we have to generate code based around the stack, meaning we're going to index into either the frame pointer or the stack pointer. We're going to probably use negative offsets. If it's not on the stack, if it's on the heap somewhere, then we're going to load, there's two parts, right? There's the address of where this thing lives. Since we don't have, see, stack pointer and frame pointer are kind of a gimme, the runtime, the interpreter already has those. And on a native platform, the CPU is going to have something similar. So if it's on the heap, we don't have a preset register yet that represents that location, like the stack or the frame pointer. So in the case of a heap variable, then we need to have a register that represents the address of that variable. Now I have my interpreter supports 64 integer and 64 floating point general purpose registers that can be used for anything. And then ultimately, when we get into like a register spelling situation, right, we would start using the stack and stuff like that. So I'm a long way away from using all the registers that I've got. So the idea here is that the way the code was written on the left, I was interfacing essentially right at the assembler level. I was saying to the instruction block, hey, give me an integer register, and then I would use it, and then I would free it. And that works. It's just very wasteful. And because we're constantly allocating and releasing registers, we can't let those flow down through the various blocks very efficiently. But in the case of, say, a global variable in a program, that global variable, we could load the address into a register, and it's very possible we could use that register everywhere for that entire program to represent that variable. So I needed something slightly more higher level than what I had. Base still built on top of the assembler to allocate and free registers. I'm still using that same mechanism, but all the elements now are going to talk to this context thing that is managing these variables. So how does this work? So most of this stuff up here, I'm going to ignore because it's, just restructuring of other code I already had. If it's a namespace thing, we're not doing anything. If we got to get the instruction block, we need to find the frame entry for the variable for the identifier if there is one. So that could or could not be set to something valid. So then on the context, we now have allocate variable. An allocate variable will return a variable that already exists, it's been allocated, or it will create one. So we pass in the result, we pass in the name, we pass in the type, we pass in the usage, and usage here is the compiler has either flagged this as heap or stack. This is kind of hard-coded temporarily here. This should not be hard-coded though. And I'm actually kind of thinking about taking this out, and because I'm passing the type in, so we can infer it inside. But for now, I'm passing this integer reg, float reg. We pass the frame entry if there is one, and this last flag is whether or not it's a pointer. And again, I think this and this I don't need to pass as parameters explicitly anymore, because now I've got the type and I can just figure that out as I need to. So then a variable, what do you do with a variable? Well, you either read it or you write it, right? So we call read. I'm passing the access level, which I probably don't need. But we pass the instruction block, and of course, I was goofing around here. Technically, we don't need to pass both of these. It's the same thing. But again, we'll tidy that up. So how does this work? So the idea here, if we then look at the output, is you'll see that we have, identifier A address global. So that read, the very first thing it will do is it will allocate a register for the address. And if it's a stack thing, it's a little different. But if it's, for now, we'll just talk about heap things. We get a register, it has the pointer, the address of that thing. And that now is constant. I0, from this point in the code on, now points at that thing. You'll notice that earlier I0 was being used for string literals, and we can even improve this, right? We can refactor string literals so that we kind of do the same thing, right? We create a pseudo variable in the context, for the string literal, and that'll allocate a register, and then we just would reuse that register everywhere. So the second part of it is, if it's a heap thing, we need to be able to read the value, right? Because this is just the pointer. Then we have to use the load instruction to actually get the value and put it somewhere. Now, this is the next level of this I think I'm going to have to do. Internally in variable t, this thing that allocate variable creates, I'm going to need to track two registers. One is the pointer register, the other is the value register. Because then what this can do is we can issue a load, and I already have a toggle on the variable t that says, hey, have we read this thing? And we wouldn't need to reread it unless it was written. If it was written, then that would retoggle the read flag, and the next time we would do another load. So the way this code's written here, you'll notice we're loading the same value twice here. We don't really need to do that. So once I put the value register on the variable, we'll get the address move, we'll get the load. Ideally then, we would not get the second load. We would just reuse the register that's designated from the first load. And then here we would have a store, which would cause that flag to toggle. And then the next time we need to load or read that variable, we'd see, oh, okay, it's something changed it, we have to load it again. But we would reload it into that same register that we allocated up front for the value. So then theoretically, if you have a bunch of read-only code, we would do one move for the address, one load, and that's it. We wouldn't do anything for those again. And that's the whole idea. So this, I trim my example down. It still works, and it is a little less code. Not loads, but a little less. And we can, again, like I say, we can improve this. Theoretically, we can get rid of this load, at least, in this example. We would still need to do this because we changed it. But before we make it too fancy, need to make it work first. So the store is right here in binary operator. We have the variable. So what we need to do is we need to move this into the variable t right. So, but before we do that, we don't need to pass that. I don't think I need that. So let's simplify these. The other thing we can do is we can add some sanity checks in here where if a write happens but a read is pending, then and it, you know, that's an error. So that's an assertion failure, essentially. Okay, so I tidied that up. And then in binary operator assignment, write is really pretty simple. Oh, and we keep track of whether or not we've written it. This is kind of like, have we ever written it? It doesn't change beyond the first toggling. So I'm not sure what that one is. So this we get rid of, and then right here we would just say variable write instruction block. Let's see if that still works. Not sure what that extra target was. Oops. Come on. You can do it. Don't need that. Don't do that. So yesterday, I worked a little bit on fixing bugs. So specifically, there were bugs around signed integers. So I fixed some of those. Some of those were parsing bugs. Some of those were conversion bugs in the compiler. So I fixed that. We've got two's complement stuff coming through. But then I discovered there's an alignment issue. I'm not sure if it's a bug in the I think it's a bug in the interpreter, but I'm not 100% sure. So I'm still trying to trace that down. The other thing is integer literal. I need to add code on there when it infers types first we have to be able to look at the value and say, is this a 2's complement? You know, is the signed bit set? And if it is, then we need to search the signed values. And then if it's not, we search the unsigned values. And then, so I'll fix type inference for signed values. And then we're gonna, I think I need to add a sign extend instruction. I definitely need to add a sign extend to the interpreter. We don't currently have that. Okay, so let's look what we got. So we get the address, we do our first load. And this first load, by the way, is just, that's part of that first read. But because this is not like, we don't know what that register is, we're not keeping track of that, it just goes off in the ether. So we got to fix that. But then we do the actual load that's going to get used in this binary operator. So we take I3, we shift 4 over, put that in I2, we store at the address I2, so there's our store that got moved into the right. So that's good. All right. So I think this code is done. We don't need it anymore. We don't need this anymore. Which is really nice. Okay, and then, yeah, we don't need this garbage. I don't think is. I haven't tested the stack stuff, but, and there's a couple of, you know, scenarios on the stack side, but I'm not too worried. You know, everything's in one place now, and it has all the metadata it needs to generate the right stuff, so I think we should be okay. Yeah, that extra pop target I think was wrong. I'm not sure what that was. But that simplified assignment a bit, right? So I'm just going to call this variable. So we know the left-hand side in the assignment is an identifier of some kind, at least for now. We go and look up the variable from the context for that. We allocate work registers for the binary operation. We don't need this access thing anymore. So that's good. So we met the left-hand side. We met the right-hand side. But before we free the target on the right-hand side, we update the variable, we write it, which then generates the store instruction. And then we free the right-hand side variable, and we free the left-hand side, because those are temps. I love it when I can simplify things. It's always so nice. Yep. All right. We still have the right answer. So that's good. Okay. So then the question is any other code calling this? No. Or this? No. So those are going to go bye-bye. don't need that. And by doing this refactoring, I'm laying the foundation for, like I say, being able to properly spill registers and flow registers from one scope to another. I mean, it'll require some additional work, but if you have a procedure that's accessing up values, then we should be able to potentially optimize and flow registers down instead of relying on the stack for everything. Okay, so we got rid of all that. This register type thingamabob, I think I don't need. I put that on there before I put the type on here. We don't need a pointer flag because we have the type, so we'll know. All right, so what we want to do is ask the type. So if it's an integer or a pointer, we need an integer register. If it's a float, then we need a float register, otherwise, so we'll set that to false. Because that's the other thing too, if it's a pointer, we don't need to do a read. We don't need to do a load. All we need to do is set the register to the pointer value and we're good. So we'll set requires read here, and then here we can just set it to true because a float value in memory is going to need to be read, whether it's on the stack or on the heap. All right, so then on type, we need a way Is it an integer? Is it a bool? Is it a float? Oh, you do? Anybody else having problems with the stream? I see, I've got it, because I'm watching myself. I always usually run the stream in a browser. Oh, well, I'm sorry. Is it? That's not good. Well, hey, Dr. Robot. Well, I think since I can, yeah, I won't refresh. I guess somebody keep an eye on Twitch and see if they fix the issue. If I have to restart the stream, I guess I can. Oh, yesterday I also hoisted out what was I going to say? I hoisted out the bool type. There's got to be a better way to do this. Let's change this. Oops. Oh yeah. Look at that. Yeah, Twitch is screwed. change my approach here slightly. It seems like there are some issues with Twitch. I haven't refreshed my browser, so I can still see my stream and it seems to be working, but I think most folks now who are trying to join or watch the stream, they can't watch it. It's not working. Okay. Now I have to go through and override these. So the default for number model is none, so I don't need to override that. So that's going to be a pointer. Bool is a value and a number. So anything that inherits from composite type is going to be a pointer. Zercan, I guess there are issues with Twitch. I mean, I'm seeing lots of error reports, although things seem to be, at least on Down Detector, the number of errors seems to be receding, but yeah, I don't know if I need to restart my stream or... Okay, there you go. What performance monitors do you use on your taskbar? Are you talking about the stuff up here? That is it's an OS 10 application called iStats Menu, I think is what it's called. And yeah, you just install it and then you can customize it. So on numeric type, we've got access models value, and then we actually cache the number class on a specific combination. Pointer type. That one's easy. Procedure types and memory. It's gonna be a pointer type. String type. Yeah, unknown types, we don't access those. Okay. Okay, so we test this. This was really just kind of removing those extra fields and coming up with a way of querying type to get to the same point. Then the next thing to do will be on variable t, we'll have two registers. One will be the address, and one will be the value. So the one we have now, we'll make that the value, and we'll add a register one because the register, or I'm sorry, the address one, the address one will always be an integer register. Okay, program still runs. No, yep, that all looks okay. All right, that's good. So then on variable t, we'll make this the value register. I don't need it. So this is going to be address reg. So we have a flag, has the address for this variable been loaded? If it's on the heap, then we're going to load the address to the address register. But so if it's an integer, yeah, you know what we should do. So we're going to allocate the address register. If usage is, hey Slayer Darth. So if it's heap, we allocate the address register. No matter what, we allocate the value register. Sweet. If it's a pointer, we allocate the address register. Actually, we can do this. If it's heap based, do that. Hey, Synox. Yep, register allocation. Fun stuff. I'm not using that anymore. What was the bool situation or bool solution? Oh, I just broke it out into a different type. I was just being lazy originally. Not, oh, it's numeric. I'll just make it numeric and just easy to refactor it. Okay, so now our variable that we're tracking in the emit context has two registers, potentially, that can be allocated. One is the address register, the other is the value register. So we only do a load from memory if the requires read is set. Otherwise, we do a move from our value register to the target register. Now, ideally, what would be nice is we'll change the code eventually to where we don't have to deal with the target register. We can just, from the usage case, we can say, oh, this variable says this is the value register. That's what it is. But baby steps, baby steps. Okay, here's the address. Here's the load. Yes. So we do a load once of the A variable. So now I1 is the value of A until we have a store, at which point we need to load it again. So that works. Beautiful. So temporarily, what I did was then, you know, the way the code's written right now, although maybe not, where's I2 coming from? Oh, that's weird. What is I2? It's interesting, it's not used. All right, so I got something goofy there. Because then we move I4 with I1, and then we use that in the computation. Then we store, we store I3, which is the result of computation, back into I0. And yeah, the output's correct. So I've just got an errant move here. Not sure what that's for. Oh, I'm sorry. I bet I know. This is probably coming from the declaration, maybe. Although I'm not sure why the target would be set there. Yeah, so then we do the store, it then loads again because we've changed it. And then of course, any place we're using that, we move the value, the current value, into a target, and which is still wasteful, but all right, so let's pick one case. Let's go back to binary operator, and let's just make a little itty bitty change. Okay, so now in read on the variable, if there's a target register, then we'll do the move. Otherwise, we ignore it. Oh. All right, let's see what that looks like. Okay. Get the address of the variable. We load it. Yeah, we're being called once without a target. Or I should say no, we're being called twice. Not sure why. We'll figure that out. We only get one load, which is good. But we're getting the move though. Because I just want I1 to flow through. We're getting that because why? Because there shouldn't be a target here. Oh wait, I bet I know. No? Yeah, this is the declaration. So we're going to get the address. We're going to do the read. There's no target. All right, so then this, yes, this is the one from binary operator. I know what's causing it. Yeah, the right-hand side has a reference to A in it. That's why. Right, so this is the left-hand side of the assignment. which doesn't have a target. This is the right-hand side of the binary assignment. So this is the right hand, which is another binary operator. This is the identifier reference in that shift instruction. And so there is a target there because the right-hand side is setting a target. Yeah, here's where it is. Da, 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 da. How do I want to do that? I mean, I'm temporarily, I mean, in this one case, I know I could safely do that. Curious to see if it generates the right code. Probably not, actually. this is kind of a test hack here. If the left-hand side, so this is handling any of the arithmetic operators. If the left-hand side is an identifier reference, then we grab the identifier from it. We look up the variable in the context, and then instead of creating a temp, we just assign the value that the variable already has. That's going to be our target. And the same is true for the right-hand side. Right, so if these things have already been loaded, they already exist, we're just going to reuse the registers that are already there. If not, right, then we'll allocate temps and operate on the temps. All right, let me see how that works. Okay. So we get the address of A, we load the value of A. Now it's assigning itself to itself. Oh, right. Because, okay, but we can fix that. We can fix it. So if the target register that comes in is different than the one that is, will create the move instruction to handle that. Otherwise, if it's the one that we want to flow through, we won't emit the extra move because it's a no-op. Yes, it's technically correct, but not what I was going for. Okay, so get the address, load the value, load up the right-hand side literal. Beautiful. Now our value flows through, and this is our second, and then the result goes back into memory. And then, of course, we've modified it. So then the next time we access it, we need to reload it. So we reload the value. Okay, so now this is because of the argument stuff, right? So we can get rid of this extra nonsense here. It's kind of the same thing, right? Like when we push arguments, we're gonna want to do the same thing I did with this. We're gonna want to say, hey, is the element an identifier reference? Look it up, you know, use that register. Otherwise, go ahead and make the temp. Void conf fill. Hi, Jeff. Why are you not using unit integration tests? Unit testing. But already the amount of code we're generating is smaller. So let me look at this. But first, so I guess the answer to that question as it relates to this project is I actually am trying to drive towards a integration test but or building actual integration tests. However, you have to understand, I'm building a compiler and I want to actually test things in the language itself, right? I don't want to write a bunch of scaffolding in C++ and test things on the C++ side. I would rather spend the time doing that in the actual compiler itself, in the target language itself. But, you know, it's still relatively early in the process here. And so yeah. What was I going to say? So I am going to have integration tests, and my specification is actually, so my plan is, you know, this examples folder is going to go away. I'm going to create a test suite folder. There's going to be a bunch of Basecode files in here, and those Basecode files are going to be the spec, right? They're going, you know, here's variables, here's types, here's variable declarations, here's scoping rules, and I'm going to break them up into separate files. Those will run through the compiler, and I'll have a little assertion framework and some little reporter thingamabobber, but all that's going to be code that's written in Basecode, not in C++. And again, there's various reasons why I want to do it that way. One of which is, then theoretically, I can take those source files and those become the test cases that when I rewrite the compiler to be self-hosted, that's what I'm aiming for, right? So I have a C++ bootstrap compiler, I have this test suite that's all written in Basecode, the compiler compiles those, runs those tests, and when those are working, right, then I take those, I use those in the self-hosting environment. Of course, obviously in the beginning, you know, a lot of those are going to fail, but eventually, you know, I'll get more and more of the self-hosted version done and more of the specification will pass. So that's the game plan. But I would, you know, again, unless I had like some specific class or something that I felt like I would get a huge benefit out of testing it at a unit level, I would much rather spend the time building integration tests, functional tests. I think that has more bang for its buck in this situation. You're welcome. Okay, so I've taken that blob of code where we have an element, we don't know what type it is. We want to find out if there's a variable associated to that. So now here I can say, you know, LHS var equal context variable for element left hand side, and then if that's not null, LHS reg is equal to LHS var reg, value reg I. Else and we want to do the same thing for relational. Okay, then argument list, oops, not that. So okay, so in the argument list, this is what's populating doing the pushes onto the stack. We're going to do the same thing, right? If the argument in the element list is a variable, if it can be boiled down to a variable, then we're going to set our target register to whatever the value register is of that variable. Otherwise, we're going to allocate a temp, and then everything else from there, you know, works as normal. I do need to fix that. Actually, you know what? That's stupid. Why am I doing it like that? I'm silly. I got me defer. So in the case where we allocate them, I have a defer that will then free them. This will then execute at the end of that block. Ooh, no it won't. Damn it, I never did fix that. This will die here. Crap, I can't do it that way. That's a bummer. I gotta fix that. should fix that problem. I don't know. My gut feel is that I will start writing the self-hosted compiler towards the end of the year. I mean, there's a fair amount of work to do here. I mean, but again, it's not a black and white thing. I mean, it's going to be kind of a transition. At some point, I would say in the next 30 days, the Bootstrap compiler should be sufficiently advanced that I can begin to do some things in the self-hosted version. And then I would expect that the percentage of what I can do to increase, slowly towards the end of the year. And then, like I say, by the end of the year, I do sometimes, yeah. With my recent schedule change, I don't stream as long, and my morning is kind of being broken up slightly. But in general, I would say I put in probably between 4 and 6 hours a day on it. But I'm also working on some other projects too, so sometimes it's not, time gets divvied up. Okay, get the address, load the value. So I1 is now the value of that variable until it gets changed. It's changed, and then we have to reload it. So we move the value of 4, we do the shift, we store it right back at that address. That's beautiful. We load it again because we've changed, and here you go, boom. Now we're just pushing I1 because that's where the value is. Woohoo! Nice. All right. And then we can do one more. Make it even better. But you program for more than 8 hours every day? No, actually, typically I don't. So with some rare with some rare exceptions, and when I say rare, I mean rare, I would say I average 5 hours a day of programming time. And that's somewhere between 5, I would say 6 hours is really pushing it in terms of like continuous productivity. Towards the end of like 5 or 6 hours, my brain's mush and I really can't, sometimes if I change projects, sometimes if I work on something else, I can make headway on that other thing. But yeah, fatigue definitely does start to set in around that point. So all right, so now let's do this. String literal. Would you say there's anything you find you're a newcomer to in programming these days, or that you're at the point of learning that goes beyond the need to educate on further, I guess? I mean, in terms of your own resourcefulness, which seems pretty much self-sufficient from watching you. Yeah, I mean, like, as I've said before, I have not written and don't typically use, I'm probably going to upset people by saying this, some of the fringe languages out there. Yeah, I don't use Scala, I don't use OCaml, I don't use Haskell, I don't use Racket, I don't use, F# that frequently. I've done a little bit with it. I don't use Erlang that much. There's a lot of things that I don't use on a regular basis. The observation that I would make that, oh yeah, I totally expect that nobody will use this, as I've said before. So I don't have any expectations there. And therefore, I do agree. I lump myself in with the fringe in that regard in terms of what I'm building. But here's what I would say to answer your question, which I think is maybe what you were driving toward. I have yet to find anything in software development that I can't learn. And for me at this point, if I spend a week, like if I spend 40 hours with something, I'm going to be proficient, mostly proficient with it. Within a month, I'll probably be idiomatic with it. Certainly within a quarter, within 3 months. Any lingering questions or things that I might have, they'd be answered at that point, right? So if someone came to me and said, hey, let's build this big thing in, what was I going to say? I'm trying to think of, oh, here you go. Let's build this big thing in OCaml, right? And they were going to pay me for it. I'd be like, okay. And, I tell them, hey, it's going to take me, a week to get to a walking pace with it, and it's going to take me a month to get to a proficient, fully proficient idiomatic pace with it. But here's, again, now, would I use documentation? Yes, I would use reference documentation. I would look at other examples. Would I go buy books? Probably not. Would I read books to learn whatever it is I'm trying to learn? Probably not. I would probably just more or less skim whatever reference material I would need to skim for whatever it is, whatever it is I'm doing. Yeah. So I don't know if that answers your question. So certainly in areas where, what was I going to say? Yeah, certainly in areas where I don't know something, that would be the case. Now that assumes that I have to go places that I'm not comfortable with or familiar with. But I guess the contention I've always had is that because I know assembly language on multiple processors, because I know C and C++, there really isn't anything I can't do on modern hardware. So if you approach it from that angle, then I don't it's more of a design thing, which I think is challenging no matter how long you've been coding, right? Because to design things well, such that they fit together nicely and cleanly and things are well factored and you have to hold that whole thing in your head, right? And you have to kind of be able to, I guess, come up with an execution plan of what the current state of the system is and how you want to change it into what it needs to be. To me, so you could break programming down into like maybe two modalities, okay? And I think a lot of folks that when they ask questions about learning and new languages, and they're in what I'll call modality one, which is how do I make this thing work? How do I write this code? You know, and there's lots of questions about the mechanics of whatever environment you're working in. Where should I put the header files? Why would I use angle brackets? Why would I use quotes? Why did I put that in names? But these are questions about the language and the how-to part, right? That's one modality. So I can definitely say like that, I don't even think about that stuff anymore. Now, does that mean I don't do dumb things or make mistakes, or I'm not perfect, but I don't spend any time, right, thinking about how I'm going to write the code itself. I just write it. And I think there's an analogy that could be made there. Maybe it's got some holes in it, but if I were to sit down and try to write a novel in English, which is my native language, I think it would be similar. That first modality would not be so much of a problem. Now, is the first draft going to be a masterpiece? No, it's going to be a pile of shit. And I'm going to have to rewrite it and clean it up and, polish it, even in my native language, okay? But the second modality is the design thing I'm talking about. It's how do I want to structure this? How do these Lego blocks plug together and make a big thing, right? And that modality, that you don't master per se. You don't go get a book and that book tells you exactly how to do that. Because that second modality, that I'm designing and architecting and building this thing, and here's how I want all the pieces to fit together, that's more like any creative endeavor in the sense that there's an art to, or a skill, whatever, word you choose, to making wooden cabinetry, right? Like, if you watch guys that really know how to do that, they're not thinking about how they're cutting things or shaping. I mean, they know how to do that stuff, right? That's muscle memory. But when you watch them build something really big, it's a process, and it's well, this has to go into this exact location, and so I'm going to build it this way. That's the design part. And that second modality, I mean, I think I'm pretty good at it. Am I the best? No. How do you, to me, the only way you get better at that is you have to just keep building things and failing. You have to build something and say, well, that turned out okay here, here, and here, but next time I'm not going to do that. I'm not going to use references in that case. I'm going to use pointers because then that allows me to do this other thing over here. You're not thinking about references and pointers as in how do those things even work. You're thinking these are the tools I have, and if I combine them together, I can get certain kinds of effects, right? And of course, interestingly enough, Basecode is going to introduce another layer to that, which is the metaprogramming, right? So then not only do you have alpha, which I'm kind of intentionally keeping a simple language because, again, taking that Lego approach, I want these things to build on top of each other, and I want the complexity to increase modestly as you go to the next layer of abstraction or the next layer of tooling. And it's by the fact that you can build these small building blocks in a language like Basecode Alpha that's relatively straightforward and there's not lots of flash, right? There's not lots of super fancy there. because there doesn't need to be, because you can build more complex blocks on top of it with the metaprogramming. I mean, I guess that's the distinction I would make between what I'm trying to do in like a Scala, or even to some extent like a Rust, right? Where there's more batteries included there, and I don't necessarily, I want to give you the building blocks so you can get your own batteries. But yeah, I don't know. Hopefully that answers that question. Trying to think if there's, yeah. And I think the biggest thing, and I've said this before, but it bears repeating in this context, I think. And this is very much, I think, against, well, certainly it's very much friction for modern work environments. So what is this friction of which I speak? So we have this thing, right, where if you have a job, you're supposed to show up, you're supposed to be working during these certain hours. That's how you kind of get paid. Even if you're salary, there's this expectation that your butt's in a chair and you're doing stuff during a certain number of hours. If you're an independent and you bill by the hour, you're even worse off, because the reality is this kind of work, yes, there are blocks of time where you can put hours in, but especially if you've never done something before, you're going to hit these points where it doesn't make sense to be sitting in front of a keyboard. You're not going to do anything, right? Instead, you need to go somewhere else, and you need to let your brain deal with the problem, right? And that's very unsatisfying for most managers. And certainly if you're an independent, you're not billing for that, most likely, which is a shame. But that's the reality, right? And so you have to kind of accept, in my mind, right, that the expectation should not be, no matter how experienced you are, that you're going to sit down with any one particular problem or any one particular task, and you're just always going to crank it out, right? It's just always going to happen on cue. And that's, yeah, it just doesn't work that way, right? It's a fallacy. What really happens is you sit down with something new, you build a pile of shit, and you smear the shit around for a while, and you're like, this is shit. Then eventually, whether your employer or your client or whatever appreciates it or not, you give up with that pile of shit. Then you go do something else, or you take a nap or whatever, and then eventually you will get inspiration about how you should proceed to make that original pile of shit not so much shit. And that process is iterative, and you repeat that over and over and over again. But what's even worse is, again, once you become skilled at doing this, it becomes non-conscious activity. And things that are not, prefrontal cortex, right? If somebody says to you, well, what are you doing? Or why is it taking so long? Or what can we do to, it's very difficult to articulate it. It's very difficult to put it into words and steps and, okay, well, because of the FROBAS and the bing bong, and I have to pass this and that, and this is in a different address space, and you'll maybe ramble like that, but it won't, then they'll think that you're just like totally screwed in the head, and that, oh my God, this thing is like, how can you, we need to fix this, we need to have a big crisis meeting, we need a, war room, we need to bring 20 people in here because you can't explain to me why this thing isn't, why it's taking you so long, right? So I say all that to basically say that, as a developer, you should expect that that's what's going to, happen, that you're not going to have the answer instantly, that you're not going to sit down on demand and just spew out, the solution on demand all the time. Now, certainly there's gradations of problems, right? And certain things that are bespoke and repetitious and boilerplate, you're going to be able to do those things on demand a little easier. But at the same time, again, this idea of technical debt and constantly refactoring, it is very easy for you to dig a hole and jump into it, whether you intend to or not, especially as things get more complex. So, you have to, you have to be cognizant of all that. Now, with all that said, I do think, and I still think this, if you go back to like CRC cards or the early extreme programming days when it was all in Smalltalk, I mean, to me, that's what they meant. That was what they were driving towards with unit testing and stories and CRC cards and all that stuff. The idea was, and I could be wrong, but I think the idea was, hey, we have to try to find a way to proceduralize this process that we go through. This thing that happens in our brains, that cause us to not be able to do things on demand and do things consistently, and that the outside world doesn't understand that. They don't know what to do with us when we tell them, oh, we're deep in it, go away. I think the idea, which had a reasonable underpinning to it, was, hey, how can we somehow proceduralize this so that we're more consistent, right? The problem is, you're going to have success with that to varying degrees, and you can only paper over or plaster around the realities of how creative behavior works fundamentally to some minimal level, right? The worst is when you've done the best you can given the limitations of your platform target and they don't even appreciate the effort. Yeah, I mean, again, yeah, this is where, exactly, this is the challenge, right? The reality is you may not be producing voluminous amounts of code, and that can be very challenging when you're trying to interact with people who aren't in that mode, right? And actually, I have something to say about that, but first I need to take a short break. I will be right back. Actually, I think I have more time today, so I'll be right back. Okay, sorry for the cliffhanger. So, years ago, I found this really awesome website. Unfortunately, I think it's mostly gone now. Yeah, this is like, okay, so these are the guys that had that original website, but this is like they've changed some of it because they're, I think they're trying to sell stuff. But the gist of it is that one of the gentlemen who did the Programmer Stone website, he was a consultant, and he kind of saw these same patterns over and over again. And the very first time I read it, you know, he had this notion of what he called mappers and packers. So what does that mean? What that means, his premise, which I think has some validity to it, is that there are essentially two different groups of people that work in a company, and the majority are what he termed packers. What's a packer? A packer is somebody who, step one, I go over to this machine and I pull this lever. Step two, this thing comes out and I take that thing over here and I put this, you know, green stuff in it. Step three, I take that back and I write down on a piece of paper that, you know, I filled the green thing and it's this time and these are my initials. And then I take that and I put it back in the machine, and then I pull another lever, and then I wait exactly 8 minutes, and then I repeat the process. That's a packer, right? And there's a lot of work, right? That's administrative, that's bureaucratic, that fits that model, and it's all prefrontal cortex. It's all, this is the first step, that's the second step, that's the third step, that's the fourth step. And if you stop any packer at any moment and you ask them, what step are you on, right? What are you doing next? They can tell you, because that's the nature of the prefrontal cortex. It's the executive function engine in your brain. It knows I'm on this treadmill and it's going to loop around and do this, and then, you know, this is what's going to happen. Now, there's a subset of people who work in companies that are what these gentlemen originally coined the term mappers. What do mappers do? Mappers, they solve creative problems, right? They solve complex lateral thinking type situations. And in order to do that, you have to get into flow, which is this non-prefrontal cortex mode. In fact, the prefrontal cortex tends to kind of go to sleep when you're in flow, which is why time dilates. And when you're in flow, your sense of time, if it doesn't outright disappear completely, it significantly alters. Because again, that prefrontal cortex is not active anymore. And your brain can't, the thing that keeps track of time is there too, right? Because sequencing is related to executive function. But if you're doing all this lateral, you know, thinking, then you don't need that. Why'd they call them mappers? Well, they called them mappers because, and again, one of these guys is a programmer, so a lot of this was in the context of programming. You know, what do you do when you're a programmer? Well, you load up the state of whatever it is you're working on in your brain, right? I hold this compiler in my head and I can think about it. I can jump around in my head and I can think about different parts of this project, and I can play what if scenarios, and I can shuffle things around. I can, like, in my opinion, as esoteric as this sounds, I mean, I can think through things and think, oh yeah, that's not, if I do that, that won't work. because I have a concrete enough map of what it is I'm doing in my head that I'm able to move around it, right? And I'm able to kind of manipulate it. But just like, Sherlock Holmes's, what did he call it? His mental castle or whatever. It's kind of the same idea. But in order to do that, there are some restrictions, right? You cannot be interrupted. You can't have other people coming at you from the outside with completely orthogonal information, right? Worse, you can't have people coming to you forcing you into executive function mode, forcing you into prefrontal cortex mode. Oh, hey, hi, my name's Cindy and I'm from HR and I need you to fill out this form because you never sent it to me. Boom, a programmer's day, it's shot, right? If you had been working for 2 or 3 hours on a problem and Cindy came up and did that to you, you're screwed, right? You're gonna be pissed off, you're gonna be cranky, you're gonna be like, now I need to go do something else for a while so I can get back into it. And oftentimes when that when that happens, it's very difficult to get back to where you were, right? And this is one of the biggest complaints programmers have with non-programmers. And I would genericize it one step removed. I would just say this is a problem that most mappers have with packers. Most creatives have with non-creatives. This is, Paul Graham has a essay, great essay. It's called Maker's Schedule, Manager's Schedule. Read it. It summarizes perfectly why programmers and managers can't seem to get on the same page when it comes to meetings. Why? Because managers are, for all intents and purposes, packers most of the time. Their context switches basically every hour, and they're going to go from one meeting to the next meeting to the next meeting to the next meeting to the next meeting. They don't typically have to hold anything in their head because whatever meeting you were in at 8 o'clock in the morning is going to be different at 9, right? And then the topic's going to change again, it's going to change again, it's going to change again. It's all administrative, right? It's all procedural. And so with that, now you have these folks where their context literally shifts every hour, mostly. And then you have people like programmers who they want their context to stay the same. They want to come in at their start time of their day and they want to load the problem state up or adjust it slightly. And then they want to be in that virtual world, right? They want to be in that problem space in their head, and they want to stay there for the day. But you have all these outside influences that are constantly, they need you to fill in a timesheet. They need you to go to this meeting. They need you to talk to these people. They need you, and you're done, right? Like this is the challenge. And again, I would go back to when I look at extreme programming, I see an attempt by programmers to create a set of procedures that the outside world, that the non-programmers, the packers can understand. But at the same time, those technical exercises are intended to kind of keep programmers in flow, right? In state. This is why, like if you look at something like XP and you compare it to like Scrum it's not as good on the surface because there's no technical exercise. You can, of course, Scrum folks will say, oh, you can do that yourself, but that's easier said than done, right? So anyway, yeah, that was a long tangent, but it's true. And I mean, I've been in many dozens of companies, and I've seen this pattern play out over and over again. And yeah. And of course, once you understand it, once you recognize this is happening, then you can kind of sort of start to adjust your engagement and the environment you're in to try to get to a better equilibrium with what you're trying to do creatively and the rest of the organization, right? Sometimes that succeeds, sometimes it doesn't, but okay. So with that change, I should I need to do one other thing. So now we need to add string literal here. Oops. Lee says, Lee, comma, Michael, is there any problem you're trying to solve with Basecode? Yes, and I will try to answer that here. Again, going back to that analogy about Legos, building blocks, I was playing with some electronics the other day, and one of the things about electronics, especially digital electronics, but it's pretty much true across the spectrum, is things are very componentized. And you can get a data sheet for a component, you know how it operates, you know how to integrate with it, and you know that's how people build electrical systems nowadays. Nobody is going, I mean, there are some, right? But a handful of companies are going back to, you know, a substrate for transistors and designing things from absolute scratch. Most embedded system stuff, you're taking existing components off the shelf and you're combining them. I mean, even at that level, like if you take like a Mac or a PC and you look at the motherboard, yeah, there's probably some proprietary stuff on there, but I mean, most of those components are off the shelf. They're reusable. And that world has a level of reuse that the software world just has never been able to accomplish. And it's my contention the reason it hasn't been able to accomplish that is because we're missing something. We're missing a building block. And my theory, which I'm going to try to prove out here by building this and using it, is what's missing is the metaprogramming. What's missing is you can't just build a function, right, and have it. You can in some cases, but there's limits to what we think of as reuse right now. What's missing is a way of reconfiguring things at compile time so that they fit into the situation that they find themselves in. And the key with the metaprogramming is to find a way, for me, right, my goal is I want the metaprogramming to be approachable, right? So like Lisp has some of this, but the syntax is bizarre and it's all runtime and it just doesn't fit and it isn't as accessible as you would want it to be. So one of the goals I have is I want the metaprogramming to be as seamless as possible. I want it to be something that you can, grab that out of the toolbox, be like, oh yeah, I know how to do this. I just write the same Basecode syntax that I always write. So to me, the metaprogramming addresses several issues. One, it addresses fit to purpose type issues, right? It addresses boilerplate and repetition. It addresses problems that now we probably are over solving with runtime behavior because it's easier, right? In the languages we have now. So we tend to then have languages that are dynamic or they have really heavy type systems at runtime. And so you're doing reflection, lots of heavy reflection at runtime to try to solve these problems because there's no convenient way to do it at compile time. And I also think, again, going back to that design thing, that second modality, it's my experience that the really complex problems are these cross-cutting things that happen in a code base. It's not, some problems and some solutions modularize very well. But it's a lot of problems and a lot of solutions, they cut across modules or cut across whatever unit, you want to talk about, be they procedures, modules, whatever. So that's kind of, in a nutshell, what I'm trying to ultimately get to with Basecode. And we'll see. We'll see how well it does. And I've said this before, I'll repeat it. Again, there are languages today where you can do some of this stuff at runtime, right? Certainly, the more scripty and high level and runtimey a language ends up being, the more, of course, you can do. Like Ruby is a pretty good example. If you can live within the constraints of what Ruby is, then yeah, you can do a lot of this stuff I'm talking about because it's all happening at runtime. But you're paying a price for that. You're paying a significant price for that. And I do a lot of embedded stuff, and I want to have a language that doesn't immediately shackle me to a garbage collector and a runtime and when I run the damn thing, it's gonna, allocate 200 megs because, right? I want to be able to really build things that are still low level if I need them to be, but I can use this metaprogramming capability to change the way in which I code the solution. But at the end, it all boils down to these low level things that are portable across machines and optimal, right? So, yeah, that's the idea. Yep. Okay. So we load this string literal into I1, but then we push I0. Oops. Yeah, that's not right. Okay, did I miss something? Oh, I think that's the mistake I made. So with normal programming languages, you have variables, loops, functions, arrays, and you build your programs with those building blocks. Basecode will have features for programmers can create new building blocks. Correct, yeah. So the idea is, again, the foundation is the same. You're going to have numeric variables, we have strings, arrays, there's going to be a variant type, right? There's pointers. You'll have loops, conditionals, namespaces, modules. That's pretty much it, right? Basecode Alpha is not super complex, right? But the metaprogramming then lets you build those building blocks with code, right? And so think of it like if you had a machine, if you had a factory that could always, if you told it, here are some parameters around a problem, and it went out and generated a bunch of code for you that did that. But you were in charge of how it built that code, right? It's not a black box. It's not some tool that you bought that doesn't work because it can't adjust to fit your situation. You are in control of that process. You can build the code that builds the code. And that's the idea. Is what you'll discover is oftentimes there, in software systems, there's this repetition. There are these patterns. I mean, that's another way I've tried to describe this in the past. Everybody knows about software patterns, right? Design patterns, gang of four. The thing about pattern languages is it puts a huge burden on you, the developer. You have to read about the pattern. You have to conceptualize and internalize it. And then whenever you want to use that pattern, there's no tool that's making that happen. That's you making that happen, right? So every time you want to use the strategy pattern or the factory pattern or the flyweight pattern or the whatever, right? You have to write that code in situ over and over and over and over and over and over again. What if you could actually make a language that described the pattern and the configuration of it, and then you had this meta program that would just go do that? It would just, become the factory that builds these things. And so the way I've described it as, Basecode is going to allow you to design your own languages, which is true, but those languages are really, the intention there is you'll build a grammar that allows you to describe a pattern that allows a meta program to run as part of that generates all these parts. And so that's the idea, right? And theoretically, if I get it all working right, there isn't anything you couldn't encapsulate with that concept, right? And so if you take that to its logical conclusion, that means you can have programs that build much larger programs and much more complex programs. Rust macros aren't. See, the problem with a lot of the macro syntax, Scala is probably closer, D is probably a little closer, even still. But the problem with a lot of the macro systems that are out there is they're insufficient. So I have no doubt that, let's say a year from now, I've got this thing self-hosted. I've got the meta programming stuff all working. I've got the syntax that you can define your eBNF and you can define your translators. I have no doubt that people will, on Reddit and Hacker News and everywhere else, will rail against how idiotic I am because I let people shoot themselves in the foot, right? Like, this guy actually lets them change fundamental parts of the language, and how stupid can you be, right? But at the same time, my position is all these other languages like Rust and Scala, now, maybe Scala and D are a little bit more closer to the middle of where I would want to be, but they try to be politically correct. They try to protect you. They try to limit you. They create specialized syntax that limits how your macros can be used. I don't want that. I don't want any of that. I want this stuff to be transparent. Meaning that if you work for a company that uses VB script and you want to make your VB script do something completely different than what it does right now, you could go into Basecode. You could create an eBNF for VB script. You could create a translator that builds whatever you want it to build, right? And then you could have a file that has VB script in it, but it's your version, right? Not somebody else's. And it's transparent, right? There's no funky syntax where, well, it kind of sort of looks like it fits in the language, but doesn't. So, and of course, that's just one example, right? There's all sorts of other things you could do with this, but yeah. When I played around with D, I thought, man, it's close, but D has other baggage with it, and that's the other thing too, is I want to have a foundational language that is, you know, it lets you program to the machine if you need to, right? It lets you program to the safest, lowest level that you can get, right? And it doesn't throw all this other baggage on top automatically because that was convenient for the language authors. Now, Rust doesn't suffer from this particular problem, it suffers from others, but D has the garbage collector. I don't want to throw things like that on there and, well, you wanted to be right above the metal, but too bad. I gave you language that's way up here, and now it's a real pain in the ass to do any of that stuff. So I want you to be able to build from right above the CPU up as high as you need to go. Instead of starting up here and saying, well, shit, if I jump, I'm dead, right? You know. So we're going to issue, the target is the address register. Okay. So let's go, who's consuming that? The argument list. Ah, it's never finding it. Because why? Why is it never? Okay. So it's in there. 145, 124, 119. It's like, oh, because, yeah, that's not going to work. I'm dumb. How can I do that? Okay, so in program on emit. Yeah, so here's where we emit the string literals. So this is where we would create the variable then. Because yeah, we have a context there. So fair enough. Let's take that out. Don't want to do that yet. Okay. So here in program, when we're doing the emit, right, because this is what controls the whole process, the code that's handling the global variable declaration, when we're doing string literals, we're interning, right? So we essentially need to, as we loop through the names, the identifiers, we're making the label, we're setting it, And so then we're going to allocate a variable on the context with that label name and set it up, but we're going to put it temporarily in this list, right? Because then what we want to do, we don't want to do the reads yet. We want to defer that until we get down here. So right here. We want to loop over var literals. Then we want to do var read top level block. Then in string literal, do we need to emit anything here? I don't think we do. So for now, we'll make it a no-op. Because in here is where we're handling the deal, right? We're basically saying, hey, this element, is there a variable for it? Yep, there is. Okay, great. Do the do, right? But just to test it. Slayer Darth. I don't know what kind of project manager we have when he is able to even fuck up simple things like requests for login details. Yeah, well. Uh-oh. There's no block, I bet. Yeah. I think I want to move the register allocator off instruction block. I think all that needs to move up to the assembler, especially now that I'm doing this where I want registers to kind of be global across everything. I think it just makes sense to move all that up, which will simplify it. But temporarily, this will work. I can pass in a block. Excuse me. Okay, now we're getting variables. Okay, so what should happen, yes, boom, that's what I expected to see. So right at initializer, we immediately get the address of all those string literals, and those are in registers now. And so here we're gonna print whatever's in I3, so that's string literal 119. And then we're going to do whatever's in I2, which is string literal 124. So actually, let's just almost right. We're missing one of them. Not sure why. So let's look here. This is 119. This is 124. This is 145. Are we loading 145? Yes. That's I1. Okay. Oh, I think I1's getting, yeah, it's stomping on it. Oops. I think that's because that's blocks. If I move the register allocation up, then that problem will go away. So that actually shrunk the code down pretty significantly. Yeah, it's reallocating that because that's a bug. Yeah, no, that's a bug. Yeah, because it's loading the wrong. This should be a different pointer, right? Or different value. So this should be the string. This should be the variable, the count call. Yeah. Much, much better though. Much, much better. Okay. So I'm going to review what I've got. and call it a day here on the stream. And I think the next step will be, like I say, I'm going to take the register allocator out of instruction block and I'm going to move it up into assembler. Because, again, originally I put it in the block because I was allocating and freeing everything within the context of a block. But now I want to have all these things kind of flow across the entire program. So I think you just have one set of integer and float allocated registers on assembler, and that'll solve a lot of problems right there. And it'll solve that one, I think. All right, so let's look at this. I moved emit context into the root of the compiler folder. It was under elements, and it really shouldn't be there. Any type. So I added a new on-access model protected method you can override. So the individual elements can tell us, hey, this is the access model to use. Argument list. So I refactored this. It tries to look up if there's a variable for the argument. So the argument then is either it's an identifier or it's an identifier reference. And if that's the case, then we look up the variable for it if one exists. If we get a variable, then we set the correct target register. I need to find a better way to handle the distinction between address and not, but I'm going to come back to that one. If we allocate a register because there wasn't a variable, then we have to clean it up later. And the rest of this stays the same, except we only clean up if we actually allocated a register. And I have an idea for that. What I could do is, for the allocation, when I move it, what I'm going to do is I'll wrap it in another class, and I'll use RAII to take care of that freeing part. Because you'll get, an RAII wrapper back from allocate that has the register in it, and then when that goes out of scope, it'll free it. Array type, I override on access model, returns pointer, binary operator. So lots of changes in here because lots of register stuff going on. Assignment, though, is much easier than it was before. We know the left-hand side of an assignment is an identifier right now, so we try to get a variable for it. If we and then we allocate a temp for the right-hand side. We emit the left-hand side. We push the right-hand side as a target. We emit the right-hand side. Then we write the variable, right, that we got from the left-hand side, and that's it. Much, much easier, because a lot of the goofiness and complexity now has kind of moved into variable. For relational operators, we have to look at both sides of the binary operator. The left-hand side could be a variable, an identifier reference, the right-hand side could be. So we have to try to dereference those, see if there's a variable there. If there is, we use that register. Otherwise, we allocate. Same thing for the right. And then at the bottom, we only clean up those registers if we, oops, and I've got those backwards. That would have been silly. All right, that one's okay. sure I didn't break anything. All right. Yeah. I still have that bug, which I'll fix. All right. Clean up right, clean up left. Same thing with arithmetic operators. Boolean type, it's both a number and has an access model. So we return that it's a value access and it's an integer type. Compiler types, put the type access model in here, type number, class, identifier usage. Composite type has an access model, which is pointer. Element, I added in, looks like I just added the include actually. Emit context, I moved right from within the elements folder into the compiler folder because it's a more general structure. And I added the variable tstruct, which just kind of captures a bunch of data about a variable in terms of code emitting. And then it has a read and a write that takes care of, emitting the right stuff at the right time. So then on context, you can allocate a variable. So you can safely call allocate variable over and over again. If the variable's already there, it'll just give it back. Otherwise, it will define it. I got rid of current access, push access, pop access. None of that stuff's needed anymore. Free variable would remove it from the map, so we're not tracking it. Also, this will free the underlying registers. Variable lets you look up one by name. Variable for element will let you pass in an element, and then based on the types of elements we know, could potentially have a variable associated to them, we look up the variables. Identifier, I moved identifier usage, and then I got rid of emit stack-based load. We don't need it anymore. This was greatly simplified, right? So this used to be this horrible blob on the left. Now it's just, is there a stack frame for this variable? Allocate it, do a read. Super easy. Numeric type, I added, type number class to the properties. Added it to the constructor, added the data to the list, added overrides for on number class and on access model. And then the number class, we actually store that on the instance because this is kind of like a factory plus the type all in one. So we create all these numeric types and we pass those values through. Pointer type, really simple. We access it as a pointer. Procedure type, this is also a pointer access. Program. And when I say pointer access here, it's an address, I'm doing a load, a structured load in the bytecode, right, from offsets. So I'm thinking of this in terms of the assembly language that's being generated, not so much C, right? So then in program, we have to create variables for all the string literals. So we set those up, and then down here, when we get to the initializer label in the top level block, we just dump out or do a read on those literals. And because these are pointers in memory, it just generates the move instructions with the offsets and we have then registers that are pointing at those places. So we only have to do that once. We have to do that multiple times. Now, this is fairly brain dead, right? It's if you had 100 string literals in memory, we don't have enough, registers. So ultimately, this needs to evolve, right, to look at what's being used, right? So maybe there's a bunch of string literals in memory, but they're not being, half of them aren't being used, or, some of this stuff might have to get scoped, and I'll just keep iterating on it until it does everything it should. Change the maker function for numeric types. In the header file, yep, just added that. My test file, I commented out a bunch of stuff just to have a really simple test case to focus on. So we print these 2 lines. We create a variable A and assign the number 2 to it, and then we do a shift left 4 times on that, and then we print that out. And then we print this line down at the bottom. Oops, I skipped over stack frame. This was bugged. It wasn't checking to see if the parent block was null. String literal. This guy doesn't emit any code anymore, which is kind of nice, because adding those variables in the context and emitting the moves for those for registers. So we might end up needing some kind of fallback here, right? Like if this would emit if it can't find itself in the context. So again, like maybe we would pre-generate or allocate it up to some number of registers that point at commonly used strings. But then if we hit a string where there is no variable, this would handle it still. Would work the same way. String type, this has an access model of pointer. Tuple type, access model of pointer. Type, so I added the public access model and number class, which go to the on access model on number class. The defaults return none. Type info, this is struct, so it's a pointer access. All right, so I'm gonna check that in, and yeah, maybe we'll wrap up for today. Just what's up here. So I mentioned this before, and I will put this here. Why no docs? That's why I don't prematurely premature release. So both of those, if you want to be depressed, read that. And and really the reason I put those out there is people ask me all the time, why haven't you written down anything? Why don't you have any documentation? Why don't you have a written specification? It's because in theory, that's the right thing to do, right? But then what happens is everybody else's expectations are way up here, and you're like down here, like, hey, I'm just building this thing, I'm just trying to get it done, and but then you have this whole, internet culture where then they just shit over everything because, it doesn't, whatever reason doesn't meet their expectations. So my attitude there is, I would rather, like, all the source code's available. It's on GitHub. You can get it, you can look at it, play with it, but I don't have any docs, I don't have a README. I don't make it inviting right now for the very simple reason it's not ready. So when it's ready, meaning like I have accepted myself that, okay, I'm happy with what I've got, and if everybody on the internet shits all over it, okay, well, I did the best I could, or I'm accepting that it is what it is, right? But I'm not there yet. So until that day, it's all up here, and it's what the code, and if people want to watch streams, they can watch the streams, and yeah, so. Yeah, I guess. The thing is, though, it doesn't. If you're putting something out there, right, it doesn't. You're. I guess you're assuming that you can just ignore everybody, right? But obviously, that's not. It's not very practical. You can't just ignore people. I guess my point is, I would rather do the best I could to be ready, acknowledging that it'll never be perfect, but there's a difference between like posting a link on Hacker News now with like they're going to do the same thing they did to these other folks, right? It's not consumable yet. It's kind of a product mentality, right? It's not just source code. It's not just software. It's, right now it's something that's being built, and eventually then it'll go into I'll go into a productizing phase, right? I'll write the documentation. I'll write an official spec. I'll, have instructions on how to build it, how to use it, tutorials. I'll have all those parts. That's what turns a bunch of code on GitHub into a product, albeit a free one and an open source one, but it turns it into something that people can consume. And that's a whole kind of sub thing all on its own, right? So it just needs to be, I need to give it the due that it deserves. But that's going to happen later. And I think the other thing too is I've never been a big fan of design by committee, right? And I think software projects go through a cycle, a phase. Right now I kind of think of myself as the closest analogy would be like a novelist or something, right? Like Stephen King does not check in his novel source code on GitHub and ask people to start creating pull requests, right? He's not going to do that. My thought is I want to get what's in my head down. I want it to do what I want it to do. Once I get past that point, then it's hard to explain, but I guess, just psychologically, I've now moved into a mode where, okay, if people start saying, hey, what about this? What about that? What about, then I'm not still struggling to get what I want out of it, and also trying to accommodate everything else. I built what I wanted. I scratched my itch. And then, okay, now a bunch of other people are coming to me and saying, hey, can we add this? Can we add that? And maybe a lot of those are, hey, this is how you would do this in Basecode. Some of them, maybe the compiler itself changes. I don't know. But then I'm in a different headspace at that point. Now I'm kind of moved into more of like a support mode, a support and enhancement mode versus a crafting, design mode. So these are the cycles of software development. Let's see. Twitch. What do we got? David Joffe's online. Man, a lot of people aren't streaming. What do we got here? C#. Coffee and code. Oh, programming assignments. Not a ton. Noob bangs his head against the wall. Yeah, that's pretty much it, Lee. Yeah, I mean, at some point you cut the cord, right? And it's like, okay, it's not my baby anymore, per se, right? I'm willing to let it go out in the world and be corrupted. But yeah, I mean, I want to get my vision working, and then people can start chiseling away on it. So yeah, definitely follow along on the streams, and I'll continue working on it. I mean, I think realistically, like I said earlier in the stream, I'll be able to, I think, seriously start undertaking the self-host version, meaning rewriting the compiler in Basecode, probably starting that towards the end of the year. And I don't think it's going to take as long to rewrite it. However, at the same time, I want to take advantage. I want to use the compiler project in Basecode as a test case for Basecode. So I want to take advantage of the metaprogramming. And so, I might be a little slow for me to get going, in the sense that I'm going to have to start thinking about how I would do some of that to take advantage of it. So, but I would say by this time next year, right, a year from now, I would expect the self-hosted compiler to be more or less done, and ready for serious public consumption. All right, anybody have a suggestion for a raid? I could do C# Fritz. I could do this MLJware again. I think I did him yesterday. We do Toaster Fuel. Yeah, unfortunately, I had a little extra time today, but my schedule is definitely not as flexible over the next 8 months as it was in the morning. Free ice cream. Yeah. Exactly. I want ice cream. Coffee and code. Oh. I don't know. The Party Bard. All right, you guys can all help the noob. Now it's actually showing the RAID UI again. Yesterday and the day before, it was all messed up. So, all right, we're gonna raid this guy. Thanks everybody for dropping by. Appreciate it. It was a pretty good session. I got a lot done. Pretty happy with that. I'll be back online tomorrow, 5 a.m. We will continue wherever I leave off. And yep, we're gonna raid this guy. Say hi. Be nice. He says he's a noob. Maybe help him. Talk to you tomorrow. Bye.